All right, so this section is going to cover, or this video is going to cover section 10.6, where we're translating those conics. So we're going to take that center of that circle and we're going to move it away from 0, 0, or the center of that ellipse, or the parabola, or the hyperbola. So we're going to kind of still deal with the exact same formulas, but we're going to have different information. So all I'm going to do is do some different examples for you of what you could see in this section and how you could then find the equation or graph the graph. So let's look at my first one. What if I was told that I had an ellipse with vertices at -5, 1, and 1, 1. And I'm told it has a foci or focus at -3, 1. So one of the foci means just one, right? One of those points is at that. So what does this tell us? Well, let's look at the graph, and that'll kind of help us with what this information tells us and how we can go from just that information to the equation. So now the center will not be at 0, 0, so it's not quite as easy. So our first vertex is at -5, -5, 1, so about here, and our next one's at 1, 1. And then that focus is at -3, 1, 2, 3, 1. And I want that to stand out, so maybe I'll highlight it. So that's our focus, right? So we know that the vertices are on the longer side, and we know for the ellipse, and we know that the center has to be in the middle, and the focus has to be on, there's two of them on both sides. So the way that we can find the center is we take the average of the x's and the average of the y's, or find that midpoint between those 2 points that are our vertices. So for the x value, you take -5 plus 1, and you divide it by 2. Well, that's going to get you -4 divided by 2, or -2. And then you're going to take that y and do the same thing. It'd be 1 plus 1 divided by 2 to find the average, and you get 1. So the center is at -2, 1. So here's the center of my ellipse. So you find that midpoint. I tried to make that red, but man, that surely didn't show up very good, did it? So that's at -2, 1, and that's our center. We also know that that focus has to be the same distance on both sides. So we also know the other focus point is going to have to be here at -1, 1. Those are our two focus, because they have to be the same distance away from the center. We also know the formula a squared minus b squared equals c squared. This is what we used a lot of times to find that c, which was our focus. But now we have that, and we know that they're 1 away from the center, so c is going to be 1. We also know our larger, this is our vertice, our larger, our major axis here is 1, 2, 3 away from the center, so that a value is also going to be 3. So what do we know? We know we have 3 squared. We do not know b squared, and we know c is going to be 1. So we look at those distances from the graph to find our 3 and our 1, or you could count them without a graph, but I like the visual. So we know that this is a major axis, so this is a horizontal ellipse. And let's look a little more. So we know that under the x value will be the larger number, our x squared. Okay, so let's find our b. B will give us that distance we have from the center to each side here, this way. So 3 squared is 9. 9 minus b squared equals 1. Subtract the 9 over. Be careful, the negative goes with the b squared. That's going to equal -8. The positive, to get rid of the negative, divide both sides by -1. So you have b squared equals 8. Well, we can get b as the square root of 8. And that's our distance that we go, but really we like the 8 because in the formula it is b squared. Okay, so now we know the distance this way. So I can take the square root, which I don't think I wrote that down to finish my graph. I can find the square root of 8, which is 2.8, and that'll give me an idea here. Let's see. So the distance from here, so I could draw it, 1, 2.8, almost to that 3. Okay, so 1, 2, almost to that 3, so that we know what the ellipse looks like. We went out 2.8 on the y here, and then we can kind of see our graph. Ta-da! There's our ellipse. So I got the square root of 8 to find that distance there. And now we know the formula, which I gave you. I gave it to you, but they kind of left it out a little bit on when they gave you the original formulas. They did not include where the center would be. I'm not making myself very clear, but that's okay. So we would have x minus h. This is going to be when the center is not at 0, 0. Squared, oops, that should be squared, plus y minus k squared over b squared, and equals 1. And that's our general formula. When I have a squared is always going to be your larger number. So you could have that switched where you have a squared and b squared switched, and then that would make you have a vertical ellipse, right? So that this part would be a little bit wider than this way. So it kind of flips the egg the other direction. So let's put in what we know. We know the center, so we can put those in here. We know the center is at -2, 1. So we're going to have x minus that -2 squared plus y minus k, which is 1 squared. And we know under each of these is b squared. Well, a squared we know is, well, the distance was 3, so a squared is 9. So under this one will be 9, and we know b squared is 8, and then it has to equal 1, and that's our equation. Whoops, I did a little too low. And that's our equation. All we have to do really is make the double negative positive before we put it into Math Excel. So that's one way to find the ellipse, a center, any of them, using that idea of distance on a graph with vertices and foci. So you can kind of go through a problem like that one. You could also see a problem just from the formula, and these ones I'm going to do a couple of because they're a little bit tricky to remember the different methods here that we're going to use. So okay, if you're looking at this, your directions will tell you to write this in, actually I think it'll tell you, is this a parabola? Write it in standard form. Is this a parabola? Is this a hyperbola, an ellipse, or a circle? So if we look at this, to get a circle, a hyperbola, or a ellipse, you need a y squared because you need that circle shape. When you only have a y or just an x, one of them is not squared, you're going to have that parabola, which we've done in the past. So if it's a y like this one that's not squared, that parabola will go this way. If it was the x not squared, then the parabola would be sideways. Okay, so basically what I'll do for this is I'll solve for y, and everything's on this side, but I need y to be by itself, so I can move everything over, or I could be even easier and just move the y over, which is what I'm going to go with. It's a negative, so I'm going to add the y to the other side, so that I have x squared minus 8x plus 19 equals y. Now this is kind of what we've seen a lot of times before. They want it in the form where we can see the vertex. It's called vertex form. So what we do is we use the complete the square, which you probably don't remember much, but let's go through that. So what we did to complete the square is we took the number in front of the x and we divided it in half, which would give us 4. And then we took that number and we squared it, which gave us 16. And we add that 16 to both sides in a specific way. This is what we're going to do. We're going to have plus the 8x. We're going to add that 16. We still have this plus 19, and we still have a y, but we're going to actually add the 16 on both sides of the formula. I put a parenthesis around this, but I didn't change anything. But what I do to one side, I have to do to the other, or the balance doesn't stay there, and it makes it false, or not the same one that we originally started with, basically. So I added a 16 so that this one would factor, because 4, what we cut in half here, 4 plus 4 is 8, and 4 times 4 is 16, and it's plus and plus. We can make this x plus 4 squared. Here, that factors into x plus 4, and then you can write it with that square, plus 19, but I need it to equal y, so I'm going to minus the 16 over here so that I have a positive 3 equals y. This is vertex form. What is the vertex? Well, it's opposite of the x, so negative 4 and always the same, 3. And that, remember, is your vertex, is that point at the end of your U shape. And we know that this is a parabola. And I think that's the information they're going to ask for. Vertex form, they might ask for the vertex and what shape this makes. Okay, so there's our parabola. And how could we double check that we got this formula right? Put this one and this one into Desmo's calculator and make sure they graph the exact same thing. All we're doing is making the formula look different. They are the exact same formula. Desmo's calculator that you can download allows you to put in the equal sign to be able to graph it a little easier, or you could put it in from here and here to make sure they're correct as well on a regular graphing calculator, because they have to be in the form y equals. All right, let's look at another formula, because that completing this square is a little bit tricky to remember, and you have to do it a lot. Okay, so here's another one where here's just the formula, and they want you to write the formula in like the standard way we see it, and tell me if this is a circle, ellipse, parabola, or hyperbola. And if we look at this, we have a squared on both x and y's. So it's not a parabola. We're out on parabola. They're all plus, so that probably tells us not a hyperbola, right? Because you have to have the minus in there between the x's squareds and the y squareds. Maybe it'll work out with a minus at the end, but I doubt it. So it's probably a circle, or it's probably an ellipse. So let's look at writing them and using that complete the square. So we're going to first look at the x's together and the y's together, and if they're not from the beginning, you need to move them to be by each other. And what we're going to do is we're going to complete the square twice for each of these. We're going to complete the square here. First of all, they both have a 3 in front, or a 3 that can factor out. So I need to factor that 3 out so that I get x squared plus 2x. And I'm going to leave a blank spot for completing the square on that section. I'm going to put a plus because that's what's here. And I'm going to look at this next section equals that negative 3. And we'd have y squared plus 6y. So let's look at this x first. First of all, the 3 outside is going to make it a little trickier. But we take the 2 and you divide it in half, which is going to give you 1. You square the 1 and you get 1. So I'm going to add 1 to this side, but really this is 1 times 3, or to add to the other side, because you'd have to times it by the 3. So when I go to add to the other side, I can't add the 1. I have to add 1 times 3, or 3 to the other side. That's tricky. Now look at the y's. I take 6, I divide it in half, I get 3. 3 squared is 9. So I'm going to add a 9 out here. There's nothing in front, so I can add the 9 here on the other side. So I have magically added the 1 times 3 over here and the 9 here, and so I can figure out the number over here. But let's look at these. This one will factor into 3 times x plus 1 squared, because 1 times 1 is the 1, and 1 plus 1 is the 2, right? And then factor the y, and this would be y plus 3 squared, because 3 times 3 is 9. 3 plus 3 is the 6, right? Equals, well, if this is just 3, negative 3 plus 3 is 0, plus 9 is 9. Whoosh, that's ugly. Here's where we're at now. We can easily see there's a factor of 3 in front of x squared and not 1 in front of the y. So you know it's not going to be a circle because it's not going to be equal numbers. So let's divide by this 9 on both sides so that we can see this almost in standard form. So 3 divides into 9, so this side would be x plus 1 squared over 3. And plus this one would be y plus 3 squared over 9 equals 1. So this is an ellipse because the 3 and the 9 are different, and the center is at -1, -3. So let's write this stuff down. The center is at -1, -3, always the opposite of what you see, and the it is an ellipse. You could be asked to find the focus, and remember, we've done that one before, but I'm going to do it because it's a little trickier to find the focus when your center is not at 0, 0. So I'm going to move my paper up here a little. Let's go ahead and find that center. Also notice the bigger number is under the y. That does play a role in the focus, and let's look at y. Okay, so, well, and I could show a graph to show you that too. All right, so we know that a squared plus b squared equals the c squared, and the c is the distance for that foci, which we don't know on this one, but we do know a and b. Oh wait, this one is the minus, sorry. It's a plus on the hyperbola. Okay, so this is a minus. So, sorry, and then I'm going to take the highest number is always a squared, which is under the y. So it'd be 9 minus 3, as those two squared numbers equals c squared. So I end up with 6 equals c squared, which makes c the square root of 6. Plus or minus equals c. Don't forget the plus or minus. It's easy. When I square root, to forget those plus or minus there. So center, C value. How can I write the focus when the center is off and we have our C value? So think about the graph. I'm going to show you the graph of this so that you can kind of see the difference between the last one we graphed and this one, because this one has the ellipse going the other direction. So the center is at -1, -3. So that's our center. And then we know that this one is, on the y is 3 away. So 1, 2, 3. So that's going to be one of your 1, 2, 3. And we know the other ones here. These are going to be your vertices. And then the other one is 3, or the square root of 3 this way, which is what, 1 point, square root of 3 is 1.7. So from the center, 1.7, 1.7. So this is what your ellipse looks like. Mine doesn't quite, I am not good at drawing an ellipse. Anyway, it looks like a kite instead of an ellipse. So we know the focus is going to have to be here or here. So we know the x value is going to have to stay the same, which on the is the same as the center, which is at -1. So that's a little bit tricky, but the foci is going to be at the point -1. And then what we do is we take that center, that y value, and it's the y because we are dealing with a horizontal, or a vertical ellipse. So we would take that -3 that's from the center, and we add or subtract the square root of 6. And that's how I find the focus. So I could figure that out, calculate that out. For let's do -3 plus the square root of 6 first, And I just put this in the calculator, -3 plus the square root of 6 to see where it's at. It's at -0.55. Let's make sure this looks right. So we know we would be at -1, -0.55 is about here. And then let's double check the other one, which would be -3 minus the square root of 6 is going to give me -5.44. So we're over -1. 1, 2, 3, 4, 5.44, and they definitely look like they're the same distance from the center, and they definitely look like the foci. So we know that we did those correctly by adding to the y that c value. Okay, so that's a little bit tricky. Let's do one more. And this is pretty much the same problem, except it makes a different shape, just to kind of mix it up a little bit. All right, so let's see here. So if I have y squared minus x squared plus 6x minus 4y equals 6. So just looking at it, we have the two squareds. We have some minus signs in there, so my guess is hyperbola. That's just where you go, you know, when you start looking at that. It could be a circle, but let's look at what shape we have here and what we have. Okay, so we're going to match the y's and the x's. So the y, I'm going to do y squared and the y minus 4y and then group those together. And then the next one would be negative x plus 6x. That's a little tricky. Equals 6. So we never really like negative x. It just doesn't work well for completing the square. It makes everything backward confusing. So what we do if we have a negative, x squared, negative x squared, negative y squared, either one, is we take a negative out of this parenthesis. So let me keep this first one the same. We don't have any numbers, so there's nothing in front of y squared, so we don't have to take anything out, so that one's a little easier. And what I'm going to do here is I'm going to take out the minus, and that's going to make the x squared positive, but it's going to change the sign of the 6x. Okay, so all I'm doing is I'm factoring out a negative from the x squared, but I have to remember to change that sign of the 6x. So that's where most people will make a mistake on that one. Equals 6. So then from here I have my two parentheses that I'm going to make complete the square, and now I don't have a negative or a number in front of x squared or y squared. So I take 4, half of 4 is 2, 2 squared is 4. So I'm going to add a 4 to this side. Again, add the 4 to the other side of the equal sign as well. Here, half of 6 is 3, 3 squared is 9, so I'm going to add a 9 here. But am I really adding a 9? I have a negative out front, so what do I have to do to that 9? I have to times it by the negative that I took out. So 9 times negative is basically a negative 9. So instead of adding, I have to minus that 9 over here, or add a negative 9, however you want to think of that. Okay, so then this one's going to factor into y minus, because there's a minus here, 2 squared, minus, and then this one's going to factor into x minus 3 squared, because of the minuses on both fronts. Those stay minuses. And then 2 squared is 4, 2 plus 2 is 4, 3 squared is 9, 3 plus 3 is 6, so you use the 3. Okay, and then 6 plus 4 minus 9 is 1. Right? 10 minus 9 is 1. All right, that's our formula. That's it. So this one is kind of tricky with that negative, but what does this form right here? It already equals the 1. It forms a, what's got in the middle? A hyperbola. So if it has the minus, it's a hyperbola, but the center is not at 0, 0. The center is at 2, 3. Remember, opposite of what you see. Oh, and oops, and I wrote these backward. Y. I said y and x. I just wrote them down. 2, 3. X goes first, then y. Oops. So 3, 2. All right, and then you could be asked the focus of this one. What else could you be asked? I think that's, you could be at, well, let's look at the focus. So we know for this one, the foci, let's look at the distance. Well, we don't really have a number underneath these, so we would use a 1. So that's our a squared and our b squared. And remember, this one you add them on the focus. So a squared plus b squared equals c squared. And b and a are 1 because we don't have numbers underneath to make those distances different than 1. Equals c squared. So 2 equals c squared, or the square root of 2 equals c. And if we go to look at that focus, we know that this shape, I'm going to sketch a graph. It's not going to be super good. -3, or 3, 1, 2, 3, 2 is our center, kind of our center there. And then from there, we know we're 1 distance away, 1, 1, 1, 1, and this shape is going to be something like this. Because it's got the y first, so our shapes, our y has to be our, I can't remember if they called that a vertical hyperbola. That's where I was kind of hesitating. I can't remember what they call it when the shapes go from the top and bottom, but that's how they're going to go because y is first. And our focus would be at 3, because it's going to be in that same line with the center, is going to be 3, and then the y value is 2 plus or minus, oops, which I forgot plus or minus on that, square root 2. Right. I can't remember if they'd ask you anything else about the hyperbola. They may. Anyway, that's kind of the idea. I think they might ask just what shape that is. So you have to start out, group x's and y's, factor out to where you have x squared and y squared with no number in front or no negative in front, and then you complete the square, and then you find whatever information they want, whether it's a graph, just telling what kind of shape it is. But there is kind of an idea of how you do this section.